Hi, my name is Maciej Szwed. I'm a software developer in SPDK team, and today I want to show you how easy it is to use SPDK with OpenStack. First, I'm going to talk a little bit about SPDK, then I'm going to talk about OpenStack and SPDK and OpenStack integration, and then I'm going to show you how actually use it. So, imagine yourself SPDK as a kit car. Okay, who knows what is a kit car? Raise your hand. Let me quickly explain that. A kit car is a usually high-performance car that you can buy, and then the factory sends you all the parts of this car required to build such a car, but you have actually assembled it by yourself. Sometimes they can also send some people to help you with that if you request that. So similar SPDK is focused on building from that high-end parts from blocks, provides that blocks to build such a car, such a application. And the people that SPDK provides to help with that is community. SPDK also provides some tools to do that. Configuration files, JSON RPC calls, and SPDK CLI tool. So now that I can build a car, what about, I have this really nice V12 engine, I have that turbo kit, I have that nice transmission, but what about a body of a car? What about the orchestration, the cloud infrastructure? A few years ago, we came with idea to integrate SPDK with some orchestration. And for that, we considered OpenStack and Kubernetes. Finally, the decision was to go with OpenStack. And we selected OpenStack because it's API-driven access to compute and network and storage resources. It supports the largest number of storage and networking systems. It has flexibility to deploy bare metal VMs and containers. It's continually evolving, and it's more mature solution, a much more mature product with bigger community. So before we go further, let me talk a little bit about OpenStack itself, because maybe not all of you are familiar with what is OpenStack and how it's built. So the definition is that OpenStack is an open source software for creating private and public clouds. And OpenStack is actually a set of specialized services which altogether provide a framework to build clouds. Three most important services are Cinder, which is a block storage service, Nova, which is instances provisioner, and Neutron, which is a connectivity provisioner. And OpenStack also provides tools to manage all of this. One of them is OpenStack Client. It's a command line-based interface to manage OpenStack. And second one is Horizon. It's a web-based service to manage OpenStack. Okay, so now that we know what is OpenStack, let's talk a little bit about history behind adding integration of SPDK and OpenStack. In 2016, SPDK team created a proof of concept of SPDK working together with Cinder and Nova using NVMe over Fabric's RDMA target. And it was presented at OpenStack Summit in Barcelona. Later, in 2017, a joint project started with Mirantis, Mellanox, and OpenStack community to add NVMe-based infrastructure to Cinder and Nova. It was the kernel version, not the SPDK yet. In the same year, work started on adding support for logical volumes in SPDK. Because at the time SPDK didn't support all the functionality that actually Cinder requires from storage backends. And in 2018, with OpenStack Rocky release, kernel and VMF target became available in OpenStack. And with that, we could start our work on integrating SPDK. And exactly a week ago, with OpenStack String release, SPDK also became available within OpenStack. Okay, so let's talk a little bit about what was done to achieve that. We created two new drivers within Cinder, SPDK volume driver and SPDK NVMF driver. First of them is used to manage all operations on volumes, on snapshots, to create volumes, to provide them. Second one, SPDK NVMF driver is used to manage NVMF target on SPDK side, to create subsystems, to attach volumes as namespaces, and to expose them to Nova. So as we have everything, we can now use Nova to create VMs, and that VM will use kernel initiator to connect to SPDK NVMF target and to attach volume. Okay, so with that new drivers, we support all the basic Cinder operations, which are managing all the operations on volumes and as well as snapshots. And for that, on SPDK side, we are using SPDK logical volumes. And thanks to that, actually, we can use any SPDK BDEF underneath, because we take any SPDK BDEF, we create logical volume storage on top of it, which serves as a volumes pool for Cinder. On OpenStack side, we use for that SPDK Cinder volume driver, as I mentioned before. Also, we support attach and detach volume operations, and we can create images from our volumes and create volumes from those images. And for that, on SPDK side, we are using NVMF target functionality, and on OpenStack side, we are using SPDK Cinder target driver. And the result of that is that OpenStack gained very fast storage backend, and SPDK now is integrated with orchestration, with and user now can take the full solution and just use it. So basically, user now just can take this beautiful Porsche, get in, turn the keys, and drive. He doesn't need to worry about anything. So now we know what was done. So let's talk a little bit about how to use it. First, to use it, we have to configure a Cinder. For that, we will edit Cinder configuration file. In default section, we need to enable SPDK backend. We have to create a new section for SPDK backend, where first we have to configure management interface for SPDK. And for that, on SPDK side, we use RPC calls. Then we have to configure NVMF interface for connecting NVMF drives. We have to point to volume driver that we want to use. In our case, it's our SPDK volume driver, and we have to provide volume backend name. And with all of that set, we are ready to use SPDK with OpenStack. And as I mentioned before, there are two ways to manage OpenStack. I want to show you both ways, and I want to show you how to create volume, how to create compute node, and how to attach volume to compute node. First, I want to show you OpenStack client. So to create a new volume, we use OpenStack volume create command. We select the size of the volume, and we select the name for the volume. Now that the volume is created, we can create a compute node. For that, we are using OpenStack server create command. We provide the flavor argument, which is a predefined set of resources that we want to provide for that compute node. We also use image argument, which is with which we select the image that we want to spawn on our volume, and we assign the name for that compute node. And now it's being built, and we can see that using nova list command. As you can see, it's being built right now. It should be ready by now, so we can run the same command again, nova list, to confirm that. And it's ready. So now if we want to attach our previously created volume to that compute node, first we have to take the volume ID, get the volume ID. For that we use cinder list command, and we get the volume ID. And for that, now to attach volume, we use nova volume attach command, where we provide the name of our compute node and our volume ID. And as you can see now, it is attached to our compute node. We can also confirm that running again a cinder list command, and we see that our volume is in use and to which compute node it's attached. We can also confirm that by logging to our compute node. So let's log on our VM. And we can list all block devices. And we see that our volume, previously created volume, 1 GB size, was attached to our compute node. Okay, so second way to achieve such operations, as I mentioned before, is Horizon web-based interface for OpenStack. So first, let's create new volume. For that, we'll go to volumes menu. When we can create new volume, and in the new pop-up window, we have to select name for our new volume. We have to select type of the volume. In our configuration files, we had only one backend enabled, so there is only one option here, but if anybody wants to use many backends and for different compute nodes to use different storage backends, there will be a full list of backends here. And we select the size of the volume. As you can see, our volume has been created. It's available for use. So now let's create a compute node. For that, we go to Compute Instances menu, where we select Launch Instances. And in pop-up menu, in Details menu, we have to set our instance name. In source menu, we set the size of the volume we require for that compute node, and we select which image we want to be spawned on our volume. Next, in flavor menu, we select which predefined set of resources we want to assign to our compute node. With that set, we can just launch our instance. So what else we can do with our volume and SPDK as a storage backend in OpenStack? Let's go back to volumes menu. And on the right of our volume, there is another menu where we can extend our volume to a bigger size. We can create many snapshots of our volume. We can upload our volume to image, so all of the content of the volume will be stored in image, which later can be used to create new instances, new compute nodes. And of course, we can also delete volume. Okay, before we go further, I want to shortly show you a snapshots menu, where you can find all the snapshots that you previously created, and we can also create new volumes out of these snapshots. Okay, so let's talk shortly about our future plans. As I mentioned before, today we use NVMF over Fabric's ADMA interface to connect SPDK and compute nodes. But as you probably already know from other presentations, SPDK also supports NVMe over TCP. And we also are planning to add this support to OpenStack to Cedar and Nova. As I previously mentioned, we also considered Kubernetes as a solution for our orchestration. And actually, we recently started our work on a Kubernetes CSI plugin. And also, we are planning to add support in Nova for SPDK vHOS accelerated storage backends. Okay, any questions? Okay. Thank you then.
Thank you.